Hi, welcome back to class. Today we're going to talk about two-dimensional lists. So as a review of what we talked about lists so far, they are a data structure containing an ordered list of elements, and these elements can be any data type, including strings, numbers, other data types, and other data structures, including lists. And that's actually what we're going to talk about today, a list containing a list. A list is a data type itself, just like integers, strings, booleans, and floats. And we talked about using the length function, indexing into them, slicing them, using the in operator, concatenating them, and iterating over them. Lists are important because they let us hold data that needs to stay in a certain order. We also talked about mutating lists, which means we change the items in the list, and we talked about append, extend, insert, remove, and pop. We talked about the difference between get and mutate, and getting information about or getting information about the items in the list does not change the original list. So we talked again about length, index, slice, the in operator, concatenating and iterating over lists. These are things that get information about the list or get items from the list that do not change the list. Now, the list functions above, append, extend, insert, remove, and pop, do change the original list. Today, we're going to talk about 2D lists. Who here has played Candy Crush before? It's a game where you have a grid and you're trying to basically match symbols with each other. So if we were to make a game like this, how will we keep track of which symbol is in each cell of a grid? Turns out we will use two-dimensional lists or 2D lists. A grid is a list of lists. The lists of the outer list each represents one row, and each value in the inner list represents a value for a column. And anytime we see a grid, we can pretty much think a 2D list. Like for crossword puzzles, Sudoku, games like 2048, tables of data, or photos, which is a grid of pixels. So let's take a look at our Candy Crush example. This is a bit of a board that you would have. And how will we represent this? Well, we have a list, and inside of this list is going to be another list. So this list is going to represent the first row. So we have blue, red, yellow, blue in that first row. We're then going to have another list that's going to represent the second row. So we have purple, green, yellow, yellow. So that second row is how it gets represented in this list. And then we have the last row. We have a wall and then orange, red, yellow. And that's going to be the last item in our list. So then we need to close the list. How might this be helpful? Well, maybe you've used IMDb before as an internet movie database. And a database is a collection of organized information to be easily accessed, managed, and or updated. So this is what a database typically looks like. We have a record, which is a row, and we have fields, which is each column. So here we have song, artist, album, release year, and genre. Let's see how we can represent that as a nested list or a 2D list. So here we have a list of lists, and the first row here is that first row in that database. So we have the song, the artist, the year, and the genre. And each of these rows represents a different song.